This week we're going to look at chemical reactions and some basics on what an equation for a chemical reaction looks like and so forth. I will post the PowerPoint version of these notes in the Google Classroom for you. A summary of what we're going to be looking at is basically the first couple of points here. We're going to look at signs of a chemical reaction, how to write a chemical reaction, and you'll look at another ed puzzle on how to balance chemical reactions. The rest of that we will be doing at a later point in time. So just as a reminder, we spent some time looking at chemical changes. Chemical changes are a chemical reaction, and what you have at the beginning before anything happens is referred to as the reactants, and the new substances that get formed are referred to as the products, and the products have different chemical and physical properties from the reactants. Atoms and mass are conserved in a chemical reaction, so the amount of mass you have in total in all of the reactants will be the same as the mass you have in total in all of the products, and all of the atoms stay the same. They are just rearranged differently. All right, some clues might tell you that a chemical reaction has happened. Release of light. So if you set something on fire, for example, you're going to release some light. You'll also release some heat. That would be a temperature change. Chemical changes sometimes can get cold. Think of those chemical ice packs. Those are a chemical change that gets cold. If you form a gas in a test tube, which is usually seen by the formation of bubbles. If a precipitate forms, a precipitate is what happens if you mix two clear solutions that have different compounds in them together, and you form a solid substance in there. That's a precipitate. If a color change happens, that's frequently a chemical reaction. Obviously, if you add food coloring to water, that's not a chemical change. That's just a physical change because you're just mixing those two substances together. Sometimes you get sounds like explosions and so forth. Many of those things indicate chemical reactions. Sometimes physical changes can do some of these. So to be sure, you really have to look and see, excuse me, if the chemical and physical properties of the products are different from those of the reactants. So an equation is a chemist's way of describing the reaction, only not having to write it out in word form. So let's say we have a chemical reaction where you're combining hydrogen and oxygen together, and when they do that, they'll form water. So you can actually literally write a word equation for that, where you say hydrogen plus oxygen produces water. So here the plus sign, very similar to what you see in math. You're putting them together. The arrow indicates that something is produced as a result of mixing those two things together. And really, you're not mixing them, you're chemically combining them. And chemists usually don't write out the words. They usually use formulas for everything. So because hydrogen is a molecule of two hydrogen atoms, its formula is H2. Oxygen similarly is a molecule of two oxygen atoms, so its symbol is O2, and when you put them together, you get H2O, which is water. All right, so there's some additional information in equations beyond what you see as a chemical formula. So we discussed the arrow and the plus sign. Frequently, letters will appear in parentheses after a substance. So this SL, G, and AQ stand for solid, liquid, gas, and AQ is something we haven't looked at before. It is what happens when you dissolve a solid compound in water. So a lot of chemical reactions occur when everything is dissolved in water, and in order to indicate that, the AQ is used as a symbol. You can also put additional items over the arrow to indicate a special condition that needs to be met in order for the chemical reaction to occur. So that last thing, the triangle over the water, over the arrow rather, means that the reactants need to be heated in order for a reaction to occur. All right, so here's a chemical equation with all of those subscripts written out, rather the state symbols written out. So here we've got aluminum in solid form is reacting with copper 2 chloride that's dissolved in water, and that produces solid copper and a solution of aluminum chloride. So those AQ and S symbols tell us something about the state in which those substances exist, and that's why they're frequently referred to as state symbols. All right, you can look at a chemical equation and describe what's going on. So here we've got solid zinc is mixed together with a solution of an HCl is hydrochloric acid. And when you do that, it produces zinc chloride in a solution and hydrogen gas. So you guys are going to be looking at equations and determining whether they've met the conservation of mass requirement for all chemical reactions. And I can look at this one and I can kind of see that I've got 1 zinc here and 1 zinc here. I've got 1 hydrogen on the reactant side, but I've got 2 hydrogens on the product side. I have 1 chlorine on the reactant side and 2 chlorines on the product side. So this does not meet the law of conservation of mass, and the Edpuzzle you guys are going to watch is going to describe how to do something that's referred to as balancing the equation so that it meets that requirement.